Now we want to take a look at some of these equations with logarithms. We'll start with the elementary ones. We know that the best way of dealing with this, log base 9 of 81 equals x, is to say, well, let's change the form of it and say, here's my menu items. My change of form says that log base b of u equals v means u equals b to the v. Well, this is the general form. Actually, that's what it's going to do, and easily we can see from there that the answer is 2, right? Okay, so that's from a most elementary level. Let's graduate up to a couple more interesting ones. Now, here's one. All right, whatever we're taking the log of, we call the argument, right? Okay, so the argument says, okay, in this case, all right, log of the square root of x squared minus 1 equals 2, okay? Well, first off, I got a couple properties of logarithms I can take advantage of. In other words, the square root is the half power, right? So we just alter that form. Now, of course, we have a log of an expression, again, the argument, to a power. And we know there's a power rule, okay, which will drop that down. 1/2 is a coefficient. So I guess that would be this rule right here. Now I can elect to, ultimately I want to get the log by itself. So I'm going to multiply both sides by 2 here, okay? Now I can convert that out to the exponential form. Okay, that would of course mean 10 to the 4th equals x squared minus 1. So I'm going to change that. So notice, rather than going directly to changing the form up here, I saw that I could work with some of the properties of logarithms and delay that. So now I'm going to have to go through. So here we go. Okay, and I'm converting that over. 10 to the 4th, of course, is what, 10,000. So if I, expand that out, simplify that, I'm going to add a 1 to it. Okay, so add 1 to both sides, right? And then I guess I have to take the square root. All right, so it looks like it's going to be the square root of 1,001 or 10,001. Now, of course, this is offering the positive and negative square root, and we have to come back and say, well, is it going to actually take both positive and negative? All right, because whatever that value is, the negative square root of a 10,001, okay, when squared, okay, is it going to give me a it's going to be squared, so it's not going to have a problem in terms of putting it back into the original equation. Okay, so there's our answer. All right, the square root of 10,001. All right, here's another problem. Now, here's a problem that involves 2 logs. All right, well, one thing we know is if we pull everything to one side, we now should be able to realize that this is the difference of the logs. And we have a rule that says the difference of the logs is the log of the quotient. And here it is over here. Log A minus log B equals log A over B. So I'm going to take advantage of that rule. And here we are. All right. Now, what I'm going to do now is I'm going to convert this out of the log form. So it's going to be 10 to the 0, which is going to be 1. And that's going to equal the argument 2x minus 5 over 8. So here we are with that. Now we can just cross multiply, and interestingly enough, we have what we would have had up here had we just lost the logs. Now I'm going to caution you against that until we can kind of prove that in the general sense, because if you make that assumption, it's going to give you in trouble. Well, that's at this point, that's a simple expression, simple linear equation, which you know, we could just wrap up, right? Just solve that, and that should be a valid answer, because again, we want to check our answers because we want to see if plugging the answer back in the argument produces a negative argument, because then if it does, we got to throw that away. Okay, let's get a couple more interesting problems of sort. Okay, let's see what this one produces. All right, well, here's the sum of two logs. The sum of two logs is the log of their product. There's our rule right there. So I'm going to put them into a single expression. The red flag comes up. It tells me the new equation may have solutions that are going to result in an undefined situation. So I want to bear that in mind. Okay. At this point, I guess I'm going to get it out of the log form. And so essentially give us this. I hope you would agree to that, right? Okay. And then, well, I guess we have to go quadratic with this. So let's simplify this here. Expand that out. We get this, right? This gives us 1,000, which I'm going to pull to the other side. Well, I guess why not just make life a little simpler, divide everybody by 100. Okay, that should make life a lot simpler. So there we are. And then we look like we got a factorable expression. Subtract a 10 from both sides. And yeah, we have a factorable quadratic, so we're gonna get the factors of that, right? Okay. So here we are, and so now that offers us two solutions: x equals 10 and x equals -1. We should realize that one of them is not a valid answer, mainly the -1, because when thrown back in this expression where it produces the log of a negative number. So we're going to find that that's not a negative. Okay, so it's going to say we're going to toss away the x equals -1 as the solution from this quadratic, because it produces an argument of a negative up here. That would make us take the log of a negative number. Okay, so there's a couple problems to think about and help you along with how to solve the logarithmic equations, and we'll look at a couple more later.